Starting now?
How so?
Starting.
8 seconds in.
I'm an idiot.
Okay.
Everybody knew
All right. The goal of 4.5, we're going to get to the goal of it at the very end of the notes. And that is to avoid trying to divide a matrix by matrix, because we cannot do that. It doesn't work. Dividing matrix by matrix, we can't do it. So we have to kind of find some other way to deal with it. So this whole lesson builds up to being able to do that. But we have to spend the whole lesson trying to get there, okay? So be patient. First thing, a matrix with the same number of rows and columns. What do you think we call that?
Square.
Aha, square matrix is correct. Point for Kayla.
I told her so. Basically, it's not for me.
What?
All right. Now, do you remember we talked about a multiplicative identity when we were talking about numbers that we said A times 1 will always equal A, right? So 1 was the multiplicative identity. We have a similar thing in matrices, but we call it the identity matrix. It acts the same way that if we multiply by it, we just get the original thing we started with.
You spelled that wrong.
I spelled it wrong? I don't think so. All right, so we denote the identity matrix with a capital I. And the N that's off to the side is just saying what size it is. It could be lots of different sizes, so we just use a letter. So here's the little formula. The matrix A times the identity I will come back to equal matrix A. Now, specifics about the identity matrix. It has to be a square matrix. It can be 1 by 1, 4 by 4, 20 by 20. It can be any size, as long as it's square. Also, what's inside, that's the part that really, really matters. It has to be a diagonal of 1s and everything else is 0s. Now let me show you what this looks like. For a 2 by 2, we have a diagonal of 1s and everything else is 0s. The diagonal has to go down from left to right. You don't have to actually draw that line, but I'm just showing you. So for a 3 by 3, we'll have a diagonal of 1s and then you fill everything else in with 0s. Do you think you could recognize identity, even if it was like giant? You'll see a diagonal of 1s and then everything else is 0s.
Sure.
You can go ahead and put that away. Now another thing that we talked about with just numbers were reciprocals. We said A times 1 over A will always equal what? Do you remember? 1. Now, in matrices, we're going to have A times, instead of reciprocal, we call it the inverse, and we write it like that, and that'll always equal the identity. And so instead of the 1, we're using identity because we're talking about matrices. So this is called the inverse matrix. This one completely depends on what the original was, okay? And we write it as A to the negative 1. All right, and I messed up. That is not supposed to equal 1. That's supposed to equal an I. Sorry. On both. So A times its inverse will always equal the identity, and the inverse times A will always equal the identity. Both have to happen in order for us to know that they are inverses. Some, but not all matrices have an inverse. So there will be some, like on your homework maybe, where there is no inverse. So you say no inverse, or it doesn't exist, or not possible, depending on what the question asks. Okay? So sometimes they don't have them. I'll show you on the back of this page how to quickly figure out whether it has one or not. Any questions so far? No? Okay, we're getting there. This first example, I'm just going to show you this to kind of prove to you that you can trust all this, that whoever came up with all this stuff wasn't just making it up. It really does work, but you don't have to do a problem like this one on your homework. Okay, we're just seeing that it does work. So it says, show that B is the multiplicative inverse of A. So what we just learned with multiplicative inverses is that if A and B are inverses, it'd be A times B equals the identity, and B times A will equal the identity. So if we can show that both those things happen, we know that B and A are inverses. So that's what we're going to do. We're going to show that. We're going to show that what A times B equals. So let's do that. So A is 2, 3, 1, 2. Times B, which is 2, -3, -1, and 2. This is matrix multiplication. That's what you've been working on this week. Yay.
Yippee.
So take the first column, or first row times the first column.
4.
It gives you 4 plus what? -3. Yep, good. Okay, now do first row times second column. What do you get? -6 plus 6. Okay. Now let's do second row and first column. What do you get? 2 plus -2. Okay, and then I need another color. Second row times second column. -3 plus 4. Okay, when we simplify all that out, what do we get?
A Z?
1, 0, 0,
1, 0, 0, 1. Is that the identity? Yes, that is what we were looking for. So check mark on that one.
Yay.
Yay.
Can I go home?
No. If we remember, you can sign off today. If you remember. Okay.
I don't understand handshakes. What are you doing on
Having a conversation over here.
gang signs?
Over
Are
here.
you doing gang signs?
No. All right, so let's do B times A. So that would be 2, -3, -1, 2. Times 2, 3, 1, 2. If this also comes out to be the identity, then we're doing good. Okay, so first row times first column, what do you get? 4 plus -3. Hey, that was the same. Okay, what about first row and second column? What'd you say? 6 plus -6. Okay, gotta change on my colors. Second row times first column. -2 plus 2. Last one. -3 plus 4. Good job, good job, good job. And if you simplify all that, we get 1, 0, 0, and 1. So are A and B inverses? So we say yes. A and B are inverses. Sometimes, fixed it, like I said, you will not have an inverse. It just won't happen. This music was loud there for a second. So we have a determinant that helps us determine if there's an inverse or not, right? Determinant helps you determine. Okay, so every square matrix with real number elements has a real number determinant. So there's a number that is the determinant to go with each matrix. Determinant. Determinants can help you find inverses. This is our matrix. This is just a general matrix. For matrix A, the elements, we call them A, B, C, D. All right, just to be able to keep them in order and refer to them. A, B, C, D. The determinant of A, we write it like this. You know that you're talking specifically about the determinant if you see, instead of bracket, you see these bars. They're kind of like absolute value in that they look like absolute value, but they do not mean the same thing as absolute value. Okay, but if you see something like that in a book or somewhere else, it's talking about the determinant. All right, that's how we write it. Now, the determinant of A, that's how we say it. Okay, we would read that as the determinant of A, or that as the determinant of A. The last thing is the actual, how do we figure this out? It's the evaluate. So we take the elements A and D, multiply them together, and subtract B and C multiplied together, and that gives us the determinant. Now, they're A and D, B and C are paired up kind of like the time periods. Like currently, this is 2014 AD, right? AD. And BC is before Christ. Y'all have any idea what I'm talking about? Yeah. Yes? Okay. These have nothing to do with that. Whatever. These have nothing to do with that, but I'm just trying to help you have a way to remember what goes together. So we're going to use that right here. So here's our matrix, and we're supposed to find the determinant of it. So we write that as, take away the brackets and just put it in bars. And that step is not totally necessary, but I want you to be able to recognize it. That's talking about the determinant. So now we need AD minus BC. So what's in the A spot? -3. What's in the D spot? Minus what's in B?
4.
And C?
2.
Okay, so what is that? 15 minus 8, which is 7. So that would be the answer to what is the determinant of that matrix. 7. Okay. We good on that? Okay, let's do the next one. So this one, taking the determinant of A0, 0A. So what's in the A spot?
A.
What's in the D spot? Minus what's B? What's C? So what is A times A?
A.
A squared. A plus A is 2A. A times A is A squared. And then minus 0, so A squared is our answer. Not too bad so far. Yay. So what can we do with that? Well, it depends on what the number that you got was. If the determinant equals 0, then A has no inverse. So if on your homework you get the determinant to equal 0, then the answer would be no inverse. No inverse. It doesn't exist. If you get the determinant to be anything else besides 0, then it does exist, and this thing is the formula. This looks really complicated, but right here and right here are the same thing. They just replaced determinant of A with the formula. So here's what I would go with. Say that this right there at the end, that's one you want to use. Whoa, sorry. equals a to the negative 1, which is the inverse of a. That's what you want to focus on. Now notice what is inside got jumbled, right? It was A, B, C, D. Now it's D, negative B, negative C, and A. That's just part of this formula, is that you're going to have to switch it all up. Okay? So the goal of this next problem is to figure out the inverse. Determine whether the matrix has an inverse. If it has an inverse, find it. Okay, so to determine whether we have an inverse or not, we can use the determinant. So the determinant of M is AD minus BC. So what's in the A spot? -2. If you need to go through and label A, B, C, D, that might help you. So we got, what was in the A spot? What's in the D spot? -4, not 21, minus, what's in the B spot? And then C, 5. Okay, so that is what? 8 minus 10. So what is our determinant? -2. Ah! You made me crazy. Based on the fact that the determinant is -2, does this have an inverse? Yes. Only when the determinant equals 0 does it not have an inverse. So this one does. So that means we get to figure out what the inverse is. Yay! Y'all are so excited.
Got it. There you go.
So the inverse, the formula for it will be AD minus BC times D, negative B, negative CA. All I did was take that from that to right there. I just recopied it. No. Now, we just need to fill in for all the A, D, B's, and C's. So, whoops, that's not a writing utensil. What was, oh, hold on. Look, we already figured out what AD minus BC was, didn't we? That was over here, so we already have that. So it's -2. Yes, I am. Okay, Jacob, what is D? No. Lila, what's D? -2. No. -4. Sorry, I heard somebody else say -2. Sorry. So we got -4. So we need negative B now. So what was B to start out with? 2. So we need to write down -2. Now we need negative C. So what did we write down? -5. And then we need A, -2. All right. Now this is just scalar multiplication. We are going to multiply everything in here by -1/2. So this will equal -4 times -1/2, -2 times -1/2, -5 times -1/2, and -2 again by -1/2. Once we simplify, we have our answer. The inverse of M equals, what's -4 divided by -2? 2. What's -2 divided by -2? +1. Hey, that gave us the answer for the last spot too, because those were the same.
21.
And then 5/2. It's positive because the double negatives cancel out. And that is your answer. So first, figure out your determinant. If it's 0, you would stop there. But if it's anything else, keep going. You plug your determinant into the bottom of that fraction, figure out the weird jumbled matrix, and then just multiply them together. Okay, so this is the point of everything. All right, it says that we are supposed to solve an equation that's of this form, ax equals b. If I gave you an equation that looked like this, a times x equals b, and I told you to get x by itself, what would you say? What should we do to get x by itself? Divide by a, right? But with matrices, we cannot do that. We cannot divide by a matrix. It doesn't work. So we have to come up with something else. So, and actually we need a little space in front of that b for what we're about to write. Go back to my blue. What did we say the inverses times each other equaled? Back on the very front page. Not 0.
Something.
Clearly something. It's on the front of the note. It's like 1, but in matrix, what do we call that? I. That equals I. So that would be I times x. Now, if we multiply the left side, we got to multiply the right side. And since order matters with matrices, we multiplied the front by that. We got to multiply the front by that.
Wait, how did you get IX?
Because the inverses times each other equal I. That was the very first problem that we did. We showed that. Okay, so now we have that I times x equals inverse of a times b. Well, what's identity times anything? No. It's kind of like 1 times anything. Like 1 times x is x. So this is just x equals the inverse of a times b. You just did a lot of work, and now you get to use this formula instead of having to do all that with every problem. Okay, you proved that x equals the inverse of a times b. Very good. Good job. So now we're going to use that to help us do this problem over here. So let's label, this is matrix A and this one as B, just so we have something to reference. We need to get, we have B already, but we need to get A inverse. So that's our goal here to start out with. And then we'll add the step of getting X. A inverse, that's just like the problem we just did. Do I need to rewrite the formula for you? Why don't I go ahead and do that? 1 over
21.
AD minus BC, and then D, negative B, negative C, and A. So we need to fill in numbers for that. If you want to go through and label, this is A, B, C, and D. That might help you.
E.
So 1 over, Coco, what goes in the A spot?
Negative 2.
Negative 2. Okay, Big K, what goes in the D spot? Huh? This 3 minus, Melissa, what goes for B? Thanks, Melissa. It's okay. Lila, what goes for C? 1. All right.
I didn't know you called Melissa.
Okay. Now, we can go ahead and fill in the rest. So, Julissa, what do we write in that first spot for D? 3, okay. Michael, what do we write for negative B?
5.
5 is correct. Jasmine, what do we write for negative C?
21.
It starts out positive. We need to make it negative, so it's negative 1. Good. All right. Kylie, you're up this time. What about A?
2.
21.
And it needs to stay the same or the same sign as it was, so we'll make it negative 2. Okay. So let's simplify down here. What is, let's just keep going down the line. Joseph. Joseph. What is negative 2 times 3? No. Negative 2 times 3.
Negative 6.
Thank you for your friends. Negative 6. Kayla, what do we get out of negative times negative 5 times 1? What do you get out of all that? Positive 5. Yeah. Okay, so Laura, what do we get on the bottom?
Negative 1.
We get negative 1. Cece, what is 1 divided by negative 1?
21.
No.
1.
And is it negative or positive? Negative 1. Okay. So, Jacob, what does it look like when we multiply that negative 1 into that matrix? What do we get? No.
-3, 5, 1,
Good job. All right. Good teamwork. You figured out the inverse. Now we just have one more part of the problem. I know. I told you. These were not going to be your favorite. It is.
Why are we doing things this difficult when I'm not even going to remember it tomorrow?
Well, that you need to remember it tomorrow. Okay. So now we're going to take that inverse and use it to figure out x. So x equals A inverse times the matrix B. Ty, what is the matrix B?
21.
Try again. It's labeled up there.
What did you say?
What is the matrix B?
-5.
No, the matrix B.
Negative 2, 2.
Negative 2, 2.
2, 2.
Now we need to do our matrix multiplication, which y'all were pretty good at a minute ago. Holden's got it.
Go Holden.
Okay, this is a 2 by 2 multiplied by 2 by 1. So what's our resulting matrix going to be? 2 by 1. It's going to be a 2 by 1. So take the first row times first column. So, Holden, what 2 numbers do we multiply first? That's not what I asked. Y'all aren't helping him any. Yeah, negative 3 and negative 2. So what do those make? What do those make? Positive 6 plus big K, what do we get out of the next 2 numbers? Negative 10. Okay, now let's see. Who wants to do the next one?
I think Miss Carter does.
Negative 2 plus what?
Yeah.
Plus 4. Okay, so here is our answer. We'll be done with the problem. Negative 4 and positive 2, right? That's your answer. You found it. Good job. You all work together.
Does that formula work for all of them or just for that one?
All of them.
Okay.
The only time it won't work is when Your determinant is 0, and that's where you just stop and you can't go any further. There is no inverse.
Okay,
Because, yeah, but that formula you use for all of them.
and what about the x equals the a?
Yes,
That one?
use for all of them, yes.
So this is what we have to do for all our problems that are not 0?
Yes.
And then.
You only have 2 problems that you have to solve for x. The last 2 on your homework.
The answer to all our questions are
21.
there.